Got to give the people, give the people what they want. All right, got this screen recording going on. So this is for all of you who want to make sure that you're ready for this Piecewise quiz that we have on Wednesday. So I'm going to pop this up. I hope you watch it, making sure that you're all prepped. All right, so let's go. Here we go. So I'm looking at this first one right here. So it says graph the piecewise function. Okay, so we have this part that says x plus 5 and this part that says 3x. So really, I'm going to graph the equation y equals x plus 5. And I'm thinking to graph this, I need to know the slope and I need to know the y-intercept. In this case, my y-intercept is 5. That's just given. And my slope is always going to be as a fraction. So in this case, the number in front of x, the coefficient is 1. So that fraction would be 1 over 1. And also like to remind myself that slope is rise over run. Okay? So let me go ahead and graph this line. So I go to the y-intercept, which is here on 5. And then I count my slope. My slope says rise 1 spot, run 1 spot. Rise 1 spot, run 1 spot. Drop 1 spot, run backwards 1 spot. Drop 1 spot, run backwards 1 spot. So, let me get rid of those now. Oh gosh, it's not going to do that. Let me go this way. Get rid of these. So, my slope up 1 over 1, up 1 over 1, down 1, back 1, down 1, back 1. So, here is my equation of this line. Lovely. Okay? Now here, with this 3x, in other words, I basically have y equals 3x. And again, to graph this, I need a slope and I need a y-intercept. In this case, I don't see any y-intercept, so what am I adding? I'm plus a 0, right? Because it's just zeros being added there, so my y-intercept is 0. And my slope, again, I want to show it as a fraction. It's 3 over 1, which is rise over run. All right. So again, now I start at my y-intercept. Here's 0. I rise 3, 1, 2, 3, run 1. I end up here. Rise 3, 1, 2, 3, run 1, end up here. If I go down 3, 1, 2, 3, I go back 1, down 3, and back 1. So here is what this line looks like, okay? So I've graphed both pieces of my piecewise function. Now the next thing I need to do, and notice I graphed those pieces without paying any attention to the domain and or range restrictions. In this case, it's domain restrictions. Now I'm going to actually take those domain restrictions into account. So this first one says that for x plus 5, for this equation right here, the x plus 5, it says that x has to be less than 0. So if I look on the x-axis, here's 0 on the x-axis. All the numbers on the x-axis that are less than 0 are over here. So that means everything, that's less than or equal to 0, this side is where this graph is good. So I'm going to erase the part of the graph that's not good. Like none of this is actually good because this is all the parts where x is greater than 0. It's to right here where it's over the part where x is less than 0. Now I need to pay attention. It says less than or equal to 0. That means I need a closed dot, which I already had there. So there is my piece of the graph. Boom, just draw my arrow a little better. There's my arrow, there's my piece of the graph. Perfect. All right, so now I'm gonna go and get rid of this. Now I'm looking at my next equation. Let me get rid of this too. I'm looking at my next equation, which is here. It says This is where x is greater than 0. Again, here are where all the numbers of x are greater than 0. So if I'm looking at this line for the 3x equation, I can get rid of all the pieces of it that are not under or over the part where x is greater than 0. So all of this can go. It doesn't count because it's not greater than 0. And now I just need to think about one more thing. Well, if it's greater than 0, that means I need an open dot at 0. So I'm going to go ahead. Ooh, don't want that, whatever that is. I'm going to go ahead here and at 0 have an open dot because 0 is not included. And now I'm in good shape. I've just created my piecewise function. Cool. All right, I'm going to clear this out. And let's look at a different one. Let's find the equation for this graph here on number 3. Okay, so I'm looking at number 3. This is the last one we'll do. I'm going to find the equation for the piecewise function. All right, I can make this a bit bigger, I think. No, I want to be able to write. Okay, so I'm thinking, all right, I see that these are two lines. These are both linears. So if I'm doing linears, I want to start off in the format of y equals mx plus b. I know that. For each of these lines, I need to find a slope, and I need to find a y-intercept for each line. So I'm going to start with this line right here. I can figure out the slope. That's easy. All I got to do is find 2 points. Well, here's 1 point. Here's another one. Rise 1, run 1. My slope is rise over run. And my slope was, I went up 1 and I went 1 to the right, 1 over 1. And I know that this thing has a positive slope, so it should be positive 1 over 1. Okay? Now I need to figure out, well, okay, I got the slope. All I need is the y-intercept. Well, unfortunately, it doesn't tell me what the y-intercept is, so I can figure it out. And I'm actually going to use the slope to figure out what the y-intercept is. So I know if I go up 1 over 1, I have to go down 1, back 1, down 1, back 1. Boom. That's where my y-intercept would have been, at this point right here, which is 1. So the y-intercept is 1. That's all I need to know for this one. So I know y equals m, which is the slope, 1 over 1 x plus 1. There's my equation for this line, y equals 1 over 1 x plus 1. All right, so I've done half the work. All right, so now let's figure out the equation for this line. Okay, so actually let me erase this other stuff. We'll use it now for this next equation. Bong bong. Cool. Again, I need a slope and a y-intercept. Well, my slope, I need to find 2 pretty points. Here's a nice pretty point right here. Here's a nice point right here. Slope. I got to put a rise over a run. My rises go up 1, 2 over 1. So my slope is 2 over 1. That's pretty good. And now I need to find the y-intercept. And I already have the y-intercept. It happens to be right here at -3. So my y-intercept is -3. So I know for this one, y equals 2 over 1x minus 3. So I have my 2 equations. I have f of x in my piecewise function equals 1 over 1x plus 1 at one spot, which is from here, and it equals 2 over 1x minus 3 at another spot right there. I'm looking good so far. Now I just need domain and range restrictions, and I will be done. So let's take a look at these and see what we can get with our domain and range restrictions. Okay, we'll start with this one. Well, we see everything starts at right here where x is 2, right? And this one, this has a closed dot. Let me clear that up. This has a closed dot at 2, and this is where x is greater than, like it's covering all the numbers that are greater than 2. So x is greater than or equal to 2 for the domain of this one. This one I see, now I'm talking about this equation, also starts where x is at 2, right? We also see it start right there, except this one doesn't happen to actually be equal to 2. And it's all happening at these numbers where x is less than 2. So we're less than. It's not equal to 2 because we have an open dot. So this is the domain of x is less than 2. I've just completed my piecewise function for this graph at number 3. All right, these are the main two things that we're going to ask you to do for this test on Wednesday. I think we'll have some answer sheets up for you, so you can practice, watch this video, think about stuff, get ready. Show us where you really are. All right, who is this? E block and F block. Have a great day.